So this is the first session on Newton's laws of motion. Okay. So in this I'll take up the issue of chapter of particle dynamics. Okay. So but before going to details of this chapter, first I will give a sort of introductory discussions I'll take up before going to the details of this chapter. Okay. First of all, we must know that c, which is a fundamental constant. C is the speed of light in empty space, which has a value of roughly 3 into 10 power 8 meter per second. This is one of the fundamental constants. So C is the speed of light in empty space. I'll write it as like this. Speed of light in empty space, which is a fundamental constant, and roughly it's a value of 3 into 10 power 8 meter per second. Okay. So now before going to details of this chapter, first what I'll do, I will I'll state the various partitions into which the entire study of physics is divided. Okay. So based on the speed of the moving bodies and the size of the material bodies, entire physics can be broken up into 4 domains, mutually exclusive domains. Okay. So I'll mention it here. Okay. So it's something like this. See, this is the C is the speed of light in empty space. V is the speed of the moving body, and this is the size of the material body. Okay. This way speed of V increases and this size of material bodies increases. So depending on the speed of the moving bodies and the size of the material bodies, entire physics can be subdivided into 4 different partitions. Okay. So I'll write down those 4 partitions. I'll state. So this is C by 10. Okay. This is the size. So if the speed of the moving bodies is less than C by 10, then it is called a non-relativistic speed. Okay. So if speed V of moving body is less than C by 10, then this speed is called a non-relativistic speed. Okay. Generally it's C by 10. It's not a watertight compartment, but generally it's taken to be this much. Okay. So we say that V is a non-relativistic speed. Non-relativistic speed. It's a non-relativistic speed. Okay, fine. So, and if V exceeds C by 10, then that speed will be called the relativistic speed. Okay, fine. It is called the relativistic speed. Fine. So, if speed of the moving bodies is less than C by 10, and size is usual normal sizes which we encounter in everyday life, not atomic dimensions, usual material bodies which we observe from our eye, whatever we observe. So if speed V of material body is less than C by 10 and size is more than those of the atomic dimensions, then this physics is called the classical physics or Newtonian physics. So this is the classical physics. When we say classical physics, we mean physics as given by Newtons. Physics as given by Newton, okay? Classical physics. One more thing, if speed V of moving body is less than C by 10 and size is also small compared to size of the ordinary moving bodies, that is the size of atomic dimensions, then this mechanics is called non-relativistic quantum mechanics. Non-relativistic quantum mechanics. Okay, fine. If speed V of moving body is more than C by 10 and size is less than the usual sizes, that is, it is of the order of atomic dimensions, then the physics which defines this domain, that is the quantum field theory, or the relativistic quantum mechanics. So this domain is called relativistic quantum mechanics. Relativistic quantum mechanics. And if speed v of moving body is more than c by 10 and size is say usual sizes which you observe in everyday life, not of atomic dimensions, more than atomic dimensions, then the physics which defines this domain, that is given by this relativistic mechanics, that is given by relativistic mechanics, that is given by this relativistic mechanics. Okay, so this is the four mutually exclusive partition of physics in which you subdivide them for the purposes of physical analysis. Okay, so first of all I would like to say that we are only interested in this part. We are only interested in analyzing this classical physics, and that too also a very small part of it will analyze. Okay, that itself is very vast. So we will just analyze a small part of this classical physics. This will be our domain of observation. Okay, this will be our domain of analysis. Fine, all right. So this I mentioned, and I also mentioned our regional domain of interest will be this, a small part of this classical mechanics, that is physics as given by Newton. Fine, all right. Now I rub this. Okay. Now, before going into details of Newton's laws of motion, I write down that in this chapter we are basically going to study the particle dynamics. Okay, particle dynamics. We are going to study particle dynamics. Okay, so now first of all we have to define what is this dynamics. So dynamics is a study of cause of motion with respect to a particular reference frame. That is called dynamics. Okay. So dynamics is the study of cause of motion with respect to a particular reference frame. With respect to a particular reference frame. That is the dynamics. Okay. To be more precise, it is classical dynamics because we are interested only in classical physics. Okay. So now, based on the complexity, this dynamics can be subdivided into three parts in the increasing order of complexity. Okay. So this is first aspect of this dynamics is particle dynamics. Particle dynamics. So what we study in this? We study the dynamics of moving bodies so small that they can be treated as particle, or we analyze the motion of rigid bodies in translation. It has been discussed in great details in the videos on relative velocity, that a translating body at any instant, all the locations of a translating body have identical motion. So if we analyze the motion of any one material point of a translating body, we automatically have full information regarding the motion of the translating rigid body as a whole. Okay. So particle dynamics, we study two things. What is that first thing? Dynamics of particles so small, objects so small that they can be idealized as particles, or dynamics of rigid bodies in translation. Of moving objects. Dynamics of moving objects so small that they can be idealized as particles, or rigid body in translation. Rigid bodies in translation. This is the domain of particle dynamics. Okay, so two things we'll study in particle dynamics. First is dynamics of moving objects so small that they can be idealized as particles or rigid body in translation. So rigid body in translation also comes within the purview of particle dynamics, because it is a fact that all the locations of a translating rigid body have identical motions. So if you analyze the motion of one material point of a translating rigid body, we automatically have full information regarding the motion of body as a whole. So one more thing I'd like to say, that they can be idealized as particles. Again, it doesn't mean atomic dimensions. Still, it's classical dimension. Okay, it's not atomic dimension. Not that small that classical mechanics is no longer valid. No, it's still more than atomic dimensions. Okay. What is the second aspect of this particle dynamics? That is rigid body dynamics. That is called rigid body dynamics. What we study in this? We study the dynamics of rigid bodies in rotation. Okay. We study the dynamics of rigid bodies in rotation. That is what we study in this rigid body dynamics. The chapter on translation and rotation has been discussed in great details on the relative velocity videos. You can go there and you can see all of them. Okay. So in the videos, if you go to that description box and press that about button, then you get all the links to the playlists which have been made in this. So if you go open that playlist, you'll get all the chapters of that video. Okay, you get all the videos of that chapter. Okay, so in this we study dynamics of rigid bodies in rotation. Dynamics of rigid bodies in rotation. Okay, so this is more complicated as compared to particle dynamics. This is an increasing order of complexity. Okay, so dynamics of rigid bodies in rotation, that comes within the purview of rigid body dynamics. Now this again can be subdivided into two parts: plane motion and 3D motion. We will be interested only in plane motion aspect. We will not go into details in 3D motion because that is highly complicated. It is much more difficult to analyze. So that is generally discussed in the full semester courses of engineering colleges. Okay, we are in high school level, so we only discuss the case of plane rotation. Plane rotation we discuss, not 3D rotation, but plane rotation. Okay. Plane rotation. And second, we have 3D rotation. 3D rotation. Plane rotation and 3D rotation. Alright. So we will only take up this part. This also will not go in this. This is highly complicated. And it's discussed in the full semester course in engineering colleges. Okay. And last in the increasing order of complexity, last is the fluid dynamics. Fluid dynamics. So in this we study the dynamics of deformable bodies. Dynamics of deformable bodies. Bodies which deform under the influence of external applied forces. This is what we study in fluid dynamics. Dynamics of deformable bodies. So this is what we study in the fluid dynamics chapter. Okay. So these are the three types of dynamics which I have mentioned in the increasing order of complexity. This is the least complicated, this is more complicated as compared to this, and this is much more complicated as compared to this and this. So, okay. So in this video I will start from particle dynamics. Okay. Now, before going to particle dynamics chapter, I would like to summarize all the important what topics we'll take up in this all the videos of this Newton's laws of motion. Okay, that I'll mention first. These are a bit. Okay. So in this chapter on Newton's laws of motion, we will be discussing particle dynamics and whose domain I have stated just now. So now in this chapter, I'll first write down, mention the topics which I am going to take up. Okay. So first topic which we will discuss is this: theoretical discussion on Newton's three laws, especially first law. Theoretical discussion on Newton's first law. We'll just now see that there are some errors in Newton's first law, which has been corrected later by Euler after 150 years later, and then it has been found to be correct. So first topic we'll take up this theoretical discussion of Newton's three laws, especially first law, and then third law, and then we'll go to second law. Okay. So theoretical discussion of Newton's three laws. Laws of motion. And then second topic we'll discuss, we'll take up the problems on Newton's second law, questions on Newton's second law. So before going, I'll just mention what type of questions I'll take up, I'll categorize them. Okay. So first what I'll do, I'll solve the numerical questions on integration based questions of Newton's second law. Integration based questions of Newton's second law. And third what I'll do, I'll take up the general theory on pseudo forces involving rotating frames. General theory of pseudo forces involving rotating NIRF, rotating non-inertial reference frame, which is written in short as NIRF. So general theory of pseudo forces involving rotating frames, and then we'll pass over to special case of pseudo forces for translating non-inertial frame. In this third point, we'll see that if we view a moving object from rotating non-inertial reference frame, whose definition I'll specify, then in general, apart from real forces, 4 pseudo forces act on the moving body, not 1, 4. Many students have wrong information that only one pseudo force acts. No. One pseudo force acts only when the moving body is being analyzed from some translating non-inertial reference frame. If you are analyzing a moving object from a rotating non-inertial reference frame, then in general, apart from real forces on the body, 4 pseudo forces act on it. So this I will discuss in great detail. This type of question was asked in JEE Advanced in 2016 when IIT Guwahati set the paper. So this concept I will discuss because this is one of very vital chapters of mechanics. So you must know fully this chapter, even if you have to go outside the syllabus also slightly, doesn't matter. But you can't compromise on this chapter, okay? So this you have to fully discuss. Then fourth, what I will do, I will take up the concept of combined equation of motion. That is also a very useful concept. Using this concept of combined equation of motion, many problems can be solved in much lesser equation. You can solve in much easier way as compared to the case if you do not know this concept. So there is a concept of combined equation of motion, highly powerful technique for problem solving. Okay. Concept of combined equation of motion. Combined equation of motion. Okay. And fifth, we'll take up the detailed constraint theory. Okay. It's very powerful theory, constraint theory. In constraint theory, we'll take up all those types of problems. We are given several pulleys, we are given several blocks. Blocks are joined together by massless inextensible strings. We have to find the tension in a particular string, we have to find the acceleration of a particular block, we have to find the acceleration of a pulley. All such things we'll discuss in this one. So this we'll see it is highly powerful theory, it's not just a trick. Okay. You have to find the relation between accelerations of various blocks given in a particular string, pulley and block arrangement. Their constraint theory is very useful. Okay. And we say it's a theory, it's not just a trick. Okay. It's not just a trick that you apply this trick, you get the answer. It has fully physical justification. And lastly, I will take up some more miscellaneous problems, okay, on this Newton's laws of motion, and then I'll close this first session, okay. I'll close the first session, I'll close. So, miscellaneous questions. Miscellaneous questions on Newton's laws of motion. Newton's laws of motion. Okay, so this is the content of this video, first video, which have fully summarized everything. Fine, all right. I hope it is clear to all of you. Okay, so in this Newton's laws of motion chapter, we will discuss only problems in which no friction is involved. And in second chapter, we take up the problems on friction. Okay, and then we take up chapter on dynamics of circular motion of a point. Okay. So this I have stated just now. In what sequence I will tell you the topics. Okay. In friction also, when you take up the problems on friction, there we will see that we are given several blocks. Okay. We are given the friction coefficient between various blocks. Some horizontal external forces applied to one particular block. Find the accelerations of the various blocks and friction force acting on the blocks. That is the main problem of friction chapter. Okay. So that is also very important. Class of questions will be involved there. So, but questions on kinetic friction, they are relatively easy. There is not much of concept involved in it. But in questions of friction, in which you have to find the acceleration of moving bodies, in which friction coefficients are given and external forces are given, there some concept is involved, because the problem is that we don't know in advance whether it's going to be slip or no slip at particular surface. That causes some problem. Okay, so that we'll discuss in great detail in the friction chapter. Okay, so this is summarized fully in first video what I am going to take up. Okay, so now in second video what I'll do, if I'll take up this one, theoretical discussion of Newton's three laws of motion, especially first law. Okay, we'll first discuss the Newton's first law of motion. Okay, we'll see that there are some problems in it. Okay, it needs some modification. So that will just not take up in the second video. Okay, so this I have summarized fully. Okay, I hope you have understood it. So if you follow it properly, you are going to get a very good advantage of it. Okay, you will be able to solve most of the problems which you get in JEE Mains in advance. I don't think there will be any difficulty. So this chapter is very fundamental chapter after relative velocity. So this has to be taken up in great details. Okay, and you have to fully know it. Especially in, for example, this case, in general theory of pseudo forces, you have to know the general theory of pseudo forces for rotating frame, not only for translating frame. Pseudo force theory for translating frame is just a special case of pseudo force theory for rotating frame. So you must definitely know this detailed theory of pseudo forces for rotating frame. This was also asked in IIT JEE Advanced 2016 when IIT Guwahati set it. So you must know this theory. So even if you have to go outside syllabus, doesn't matter. If a matter of concept is involved, if I get some advantage in solving questions on JEE Advanced and Mains, so there's no harm. I should take up this chapter. Even if I have to go slightly outside the syllabus, doesn't matter. Okay. So now I'll rub it. Okay. So now in second video, I'll take up the theoretical discussion on Newton's three laws. So in first, I'll take up the theoretical discussion on Newton's first law of motion. I'll take up the theoretical discussion on Newton's first law of motion. That I'll take up. Okay. Fine. So this I close it here. Fine. All right.